Hello friends, welcome to Study Spectrum and also welcome to 10th standard of Maharashtra State Board. Today in this lecture we'll start with a new chapter of science, that is School of Elements. Now actually going into this chapter, before we move into this chapter, let us understand and take some examples of our day-to-day life. Have you ever been to a shop, a grocery market? If you have been there, you see there is an arrangement, a pattern being followed where stuffs and things are kept. Similarly, if you go to a library and if you ask a librarian of your college or school, you will see that books are arrangement in some order wise. You will be very easy to find any sort of book of any subject or any sub-subject. Why? Because the librarian has designed, or the institute has designed, a system in which they have classified different books. Also, if you see at your home, your mom will ask you to keep clothes in a proper manner. T-shirts on one side, jeans on one side, shirts hanging from hangers on one side. Why? Because it will be easy to pick whatever you want from a particular place. So what you have done is you have classified the objects. Now similarly, if we study about elements in this chapter, it is very important to classify them. Now if you remember in your lower standards, you have learned that matter can be classified, or matter can be seen into three different forms, that is elements, compounds and mixtures. Now in early 18th and 19th century, when elements were being discovered and many scientists were taking efforts to discover elements, they found they can categorize them into metals and non-metals, and slowly a few type of elements were called as metalloids, which shows different properties or similar properties with metals and non-metals both. So it became a very important situation where you need to classify elements in a form of table. Now friends, whatever formula, whatever theories we read is not a work of a night or a day and had been presented in front of you. It takes years and lives of many scientists to present some theories and laws. Now in this School of Elements, in this chapter, what we will try and understand, there are three different scientists. Before we actually came with modern periodic table, there were three different scientists who put efforts at their time and tried to help the further scientists to make a periodic table and classify elements. In this chapter, we will try to learn how they put their efforts, what were their laws, merits, demerits and different things they have done during their time to classify elements. To begin with, we'll start with the very first scientist, that is Johann Wolfgang Dobereiner, who was a German scientist and was the first recognized scientist to classify elements. Now, before I move into their merits and demerits and the features of their laws, let me tell you one thing. The modern periodic table which we see now in our chapters or in our books, textbooks, before that there were three famous scientists who actually tried to classify elements, but all of them failed. The reason is, basis of all those three scientists were increasing order of atomic masses of the elements. Whereas in modern periodic table, the basis was increasing order of atomic numbers. So please remember that during this chapter we will try and figure out how these scientists, these three scientists, before we actually have a modern periodic table, failed just because of one basis which was common between them, that was increasing order of atomic masses. So moving further, we will try and understand what were the laws and merits and demerits of these three scientists. So the first scientist, the first recognized scientist in 1829-13, a German scientist named Johann Wolfgang Dobereiner gave the first law, that was law of triads. During his research, during his work to classify elements, he found that there were few elements who showed similar properties and formed 4 different triads. Now a triad is basically a group of 3 members of 3 elements. If you see, he formed 4 different triads. The first one was lithium, sodium and potassium. The second one was calcium, strontium and barium. The third one was chlorine, bromine and iodine. And the fourth one was sulfur, selenium and tellurium. Now the important property in all the 4 different triads is that if you see, the atomic mass of the middle element is the average of first and third, which means if you add the atomic masses of first and third element and divide by 2, you will approximately get the atomic mass of the middle element. And also if you see the trend, it is increasing order of atomic masses. As you move down the triad, in any of the triad, the atomic masses are increasing. So the law of triad which Dobereiner gave was actually increasing order of atomic masses and formed 4 different triads, stating that the middle element, the atomic mass of the middle element is the average of first and third, which you can see over here. Now, after this scientist who classified the elements in 4 different triads, Newland came into existence, and he also showed and tried to classify different elements. Now, why Dobereiner failed? Because there were many elements present at that time, but he was able to classify only 12 elements forming 4 different triads. Each triad contained 3 different elements. So he was not able to classify all the elements discovered at that time, so his triad was a failure and was not fully accepted. And please remember, like in starting I said, increasing order of atomic masses was the only basis common in 3 different scientists who are going to be followed after Dobereiner, was the reason because of their failure. Now, after Dobereiner, Newland, a British scientist from London, came and he gave a law which was called as law of octaves. He formed a periodic table in which 7 different groups were there and 3 periods were there. In this law of octaves, he stated that every 8 element will show similar properties to first element. If you choose any element from his periodic table and mark it as 1, and if you move further counting 2, 3, 4, 5, 6, 7, you'll find the 8th element falling under the very first element and showing similar properties. Now it was Newland's efforts to form such a periodic table, but the problem was that he was able to classify only a few elements, and his law was valid till calcium only, which was 20th element. There were 56 elements discovered at that time when Newland was trying to form or classify elements to form a periodic table, but he was able to place very less amount of elements in his periodic table, and above all his law of octaves was valid, was true till calcium only. Now under this law of octaves, the statement was the properties of every 8th element will be similar to the first element of this periodic table. Now if you see this periodic table, there are roughly 21 elements, and after calcium the elements are chromium, titanium, manganese and iron. Now if you analyze this periodic table, you will see that at calcium, till calcium, every 8th element is actually following the properties of first element, but the last 4 elements, that is chromium, manganese, chromium, titanium, manganese and iron, are actually not following the properties of their first element if they are the 8th element. So similarly, there were few merits and demerits of Newlands also in his law of octaves, which were, see, we have seen a law of octaves, that is the properties of every eighth element is similar to first element. So he was able to classify all the elements of his periodic table, and this law of octaves was true till calcium only. But at that time 56 elements were discovered. He was able to place only 21 elements in his periodic table, and above all the last 4 elements were not obeying his law, which was that they should follow the same property, or they should have the same properties of their first element if they are considered as 8th element. Now, after Newland gave his law of octaves, and during that time also when he was gave his law of octaves, there was a Russian scientist called Mendeleev, who was also working on periodic table, and after Newland he gave his periodic table, and the fact is his periodic table was highly recognized and appreciated, but still failed. Why? If you remember, like I said, the cause for the failure of all these 3 scientists was the increasing order of atomic masses was their basis of periodic table. Now, we have seen Dobereiner and Newlands work for periodic table, their classification of elements, they found periodic table. Dobereiner formed triads, 4 different triads, gave law of triads, that is increasing order of atomic masses was his basis, and the law was that the atomic mass of the middle element of each triad will be the average of first and third element of that triad. Then we have seen Newland's law of octaves, property of every 8th element is similar to the first element of that periodic table, but the problem was he was able to classify only 21 elements, and 56 elements were discovered at that time, at his time during formation of periodic table. Now, after these 2 scientists, they tried and were able to classify elements, form small periodic table. After these 2 scientists, in came a Russian scientist called Mendeleev, and he was the first scientist to classify all the elements discovered at that time. There were 63 elements discovered at that time, and he was able to place all the elements in his periodic table. Now, let us understand and learn how actually he was able to form his periodic table and what were the efforts he put to form periodic table. Now, when he was trying to classify elements, he used hydrogen and oxygen to form compounds with different elements to analyze chemical properties of different elements. Why? Because hydrogen and oxygen are highly reactive, and they are able to react with all the elements, 63 elements present at that time. Now, during his work and during his test and analysis of all elements, he found that the physical and chemical properties are periodic functions of the atomic masses of different elements, and that is the law he gave, that the physical and chemical properties of elements are periodic functions of their atomic masses. And this is how he classified and formed a periodic table of 63 elements. In his periodic table, there were 8 different periods and 7 groups.
No more spending your energy and money on coaching classes, or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Now, in his law of octaves, Newland gave the statement, gave the law, which was, when elements are arranged in increasing order of their atomic masses, properties of every 8th element will be similar to the first element. Now, let us see some features of this periodic table which Newland gave. In his periodic table, if you see the table, there are 21 elements, but his law was valid till calcium only. After calcium, the 4 elements which you can see in the periodic table, chromium, titanium, manganese and iron, were not following his law, which was if they are arranged in their increasing order of atomic masses, the properties of every 8th element should be similar to the first element. Now, after Dobereiner and Newland, in came a Russian scientist named Dmitry Mendeleev. Before he classified the elements, he formed his periodic table, he tried to examine the relationship between the atomic masses of different elements and their physical and chemical properties. Now, for chemical properties, he formed different compounds of elements with hydrogen and oxygen. Why? Because hydrogen and oxygen were very reactive and formed compounds with almost all elements. 63 elements were discovered at that time. Now, after his analyzation, he found that elements can be arranged in a periodic table, or he formed the periodic table that the properties, physical and chemical properties, were basically linked to their atomic masses, which means if the elements are arranged in increasing order of atomic masses, physical and chemical properties of those elements will be repeated. So what he did is he started to arrange elements from left to right, and he found that there was gradually there was degradation in the properties, and finally he encountered with an element which showed similar properties with the very first element, and he placed that element below the first element and started to arrange again the second row. In this way, he formed 8 groups and 7 periods. Now, and he gave the law that physical and chemical properties of elements are periodic function of their atomic masses, and formed his periodic table, which we can see as Mendeleev's periodic table. Now, moving further, let us understand what were the features, merits and demerits of Mendeleev's periodic table. In features, we can see there are 8 groups and 7 periods, and if we talk about merits, Mendeleev, like I said earlier also, Mendeleev was the first scientist to classify all the elements discovered at that time, and that were 63 elements. He placed all the elements in his periodic table. Second thing, if you see his periodic table, he left some empty spaces, some gaps, and stated that there are some elements which are not discovered at this time and will be discovered in future, which will show these some other properties. For example, if you talk about gallium, if you see that space was left empty, and he said that a metal will be discovered at this place which will melt in your hand itself with the warmth of your hand itself, and actually gallium was discovered later. And third, when noble gases were discovered, his periodic table was undisturbed. The noble gases which were least reactive noble gases were placed apart from his periodic table, and the elements of his periodic table was undisturbed. So these were 3 merits. First, he classified all the 63 elements present at that time. He left empty spaces in periodic table, his periodic table, stating that there are few elements which are not discovered at this time and will be discovered in future, showing so and so properties. And third, noble gases when discovered were placed apart from his periodic table, undisturbing the elements of his periodic table. Now, if there were merits, there were demerits also, because his periodic table was finally a failure. Now, what were the demerits? We will try to figure out. If you see his periodic table, hydrogen is being placed over lithium, but he was always confused where to place hydrogen, above halogens or alkali metals. So that was the first demerit, his confusion to place hydrogen in his periodic table. Now second, he was not able to classify isotopes of different elements. For example, if you talk about carbon, there are two different isotopes of carbon, that is 6C12 and 6C14. But if you see these two isotopes, they have different atomic masses, and his law said that the physical and chemical properties of elements are periodic functions of their atomic masses, which means if the element have different atomic masses, like you can see these isotopes, these two isotopes have different atomic masses, one is having 12 and one is having 14, they should be placed in different slots, but the element is same. So he was not able to justify the placement of isotopes of different elements, was his second demerit. The third demerit was, if you see his periodic table and his law that it should be increasing order of atomic masses, you see cobalt is having slightly higher mass than atomic mass than nickel, but is placed before nickel and should be placed after nickel according to his law, that is increasing order of atomic masses. So this was his third demerit. He placed cobalt having slightly higher atomic mass than nickel before nickel, when it should be placed after nickel according to his law. Now the fourth demerit was, he placed a very few wrong elements in wrong groups. For example, if you see his periodic table, manganese is placed in a group of halogens. But if you see manganese is a metal, how can it show similar properties of halogens? So this is how we have seen three different scientists, I repeat again, which is, first one is Dobereiner, who gave law of triads. He was not able to classify all the elements present at that time, formed different 4 triads, each triad containing 3 elements. The law of triad was that the atomic mass of the middle element is the average of first and third. If you can see these 4 different triads. And after that, Newlands came and he gave law of octaves, that if elements are arranged in increasing order of atomic masses, then properties of every 8th element will be similar to first element. But his law was applicable or true till calcium only, and further he was not able to classify all the 56 elements discovered at that time. After that, Dmitry Mendeleev, who actually did a very great job of classifying elements and forming a periodic table, he was able to classify all the 63 elements present at that time. He also had the same basis, increasing order of atomic masses, similar to the first 2 scientists. And we have seen the features, merits and demerits also of Mendeleev features of periodic table. His periodic table has 8 groups, 7 periods, and merits like he was the first scientist to classify all the 63 elements. He left some empty spaces in his periodic table, stating that there are few elements which are yet to be discovered and will be discovered in future, showing so and so properties. And the third, when noble gas were discovered, they were placed undisturbing the elements of Mendeleev's periodic table. And also he had demerits, because of which he was a failure. I mean, his periodic table failed and was not accepted fully. Those demerits, 4 demerits are, he was always confused to place hydrogen, where to place, I mean above halogens or above alkali metals. If you see periodic table, you see hydrogen placed over alkali metals, but he was always confused. Second, isotopes of carbon, isotopes of different elements. I am taking an example of carbon. He was not able to place the isotopes properly. Why? Because isotopes have different atomic masses, but the element is same. And according to his law, increasing order of atomic masses is the reason of placing different elements in periodic table, and isotopes of same element should be placed in different slot, although the element is same. So he was confused where to place isotopes. And third demerit was that if you see his periodic table, cobalt has slightly higher atomic mass than nickel, but still placed before nickel, although it should be placed after nickel according to his law of increasing order of atomic masses. And the fourth, if you see the periodic table, manganese is placed in group of halogens, whereas manganese is metal and cannot show similar properties of halogens. So this is how these three different scientists actually tried to classify elements, whatever the number of elements discovered during their time, and gave their different periodic table. Now in came, after these three scientists, in came Henry Moseley, who actually gave a modern periodic table which we use now in our different textbooks and chemistry. He removed all the different demerits of different scientists and gave a new law that the physical and chemical properties of different elements are periodic function of their atomic numbers but not atomic masses. And this is how he formed modern periodic table which we see now, and removed all the demerits of different scientists. Now after seeing the works of different scientists, German scientist Dobereiner, British scientist Newlands, Russian scientist Dmitry Mendeleev, and Henry Moseley, who actually gave the modern periodic table, we'll move further in this chapter and try and understand what are the different trends and different properties of this modern periodic table. If you see this modern periodic table, there are three different blocks above and one block below the main block. The first block is S block, which contains two different groups. The middle block is D block, which contains 10 different groups, and the right extreme block is P block, which contains 6 different groups. And below this you see there are 14 different groups and 2 periods, which is your F block. Now there are in total 18 groups and 7 periods in this periodic table. Now friends, let me tell you one thing. Ever you talk about periodic table, there is always a block which constructs in your mind, and slowly like a camera zooms in and the pictures becomes clear on focusing. We can see different groups and elements of this periodic table. It happens. Now let us understand different positions of different elements in this modern periodic table. If you see this periodic table, this modern periodic table, on the left side it is S block containing 2 groups. In the middle it is D block containing 10 groups, 10 vertical groups, and on the right side it is P block containing 6 different vertical groups. At the bottom it is F block containing 14 different groups, and each group has 2 elements. Now let us understand this periodic table in full-fledged manner. See, if you see this S block, there are 2 different groups. The first group is called as alkali metals, where the second group is called as alkaline earth metals. Now this S block and this P block are called normal elements. S block contains only metals, whereas P block contains all metals, non-metals and metalloids. Whereas in the middle, the D block, which has 10 different groups, are only metals and called as transition metals, whereas S block and P block are called as normal metals or normal elements. Now the block below S, D and P, which is F block, contains 2 different periods. The above period is called as lanthanide series and the below one is called as actinide series. Now this F block is actually called as inner transition elements. Now we'll try and understand why these names are given. S block and P block have only one incomplete outermost shell, whereas D block elements have 2 incomplete outermost shells and F block has 3 incomplete outermost shells. That is why S block and P block are called as normal elements, D block elements are called as transition elements, and F block elements are called as inner transition elements. Also, if you see the periodic table, in the end the 18th group are noble gases. All have their octet complete, the outermost shell complete. If you see the different periods, the first period contains only two different elements, that is hydrogen on the left extreme and helium on the right extreme. If you see the second period, there are two elements of S block and six elements of P block. In total, there are 8 elements in the second period. Whereas in third period and so on, fourth, fifth until seventh period, sixth and seventh also, there are 18 elements in each period. You can see that in periodic table. Nothing rocket science in that. Now, there are different names of different groups also. Like I said, in S block, the first group is called as alkali metals, whereas second group is called as alkaline earth metals. Whereas last group, 18th group, is called as noble gases, inert gases, because they are not reactive. And just before that noble gases group is halogens, which contains fluorine, chlorine, bromine, iodine, and so on. Now, we have seen positions and where the different elements are placed in this modern periodic table, and we have seen different blocks also, their names also, number of periods 7, number of groups 18. We'll try and understand how many electrons they have in their outermost shell, but only for S and P block, because you don't have to study D and F here. If you see the first group, it is group number 1 and it has only one outermost electron, which means number of valence electrons of elements of the first group is 1. Number of valence electrons in their outermost shell of group 2, since it is group 2, they have 2 valence electrons in their outermost shell. If we skip this D block and move into further of P block elements, the first group of P block, that is third group after first, second, we have given number to the S block groups. The third group, which is the first group of P block, will have 3 elements in their outermost shell, which means they have 3 valence electrons, all the elements of third group. First group of P block, third group after being 1 and 2 numbers given to the 2 groups of S block. Which means if we go to the second group of P block, it should have 4 outermost electrons in their valence shell, or their valence electrons is 4 of all the elements of second group of P block, but from starting it is 4th group. First and second of S block, third and 4th. Similarly, if we move further, we will find that number of valence electrons increases from 3 to 8 for P block elements or groups. The first group of P block will have 3 elements in the outermost shell, second will have 4, third will have 5, fourth will have 6, fifth will have 7 outermost electrons in their outermost shell, and the last group will have 8 electrons in their outermost shell. So this is how we have seen the positions of different elements in the modern periodic table. We have seen the names also, number of periods, number of groups, what are the blocks names, how many groups are there. We have seen different elements and their position in the periodic table. Now, this modern periodic table also have some merits. That is why it is used now as a long form of periodic table, modern periodic table. First of all, it removed all the anomalies of different scientists which tried earlier to classify the elements. Like, since this modern periodic table is based on the law that the physical and chemical properties of different elements are periodic function of their atomic numbers and not atomic masses. So that anomaly of placing different isotopes in different slot was also removed. They were placed in the same slot since the element is same and they have same atomic number but different mass number. And since the atomic numbers are same, they will be placed in the same slot. Also, if you remember in Mendeleev's periodic table, there was a mismatch, or cobalt was placed before nickel, although the atomic mass of cobalt was slightly higher than nickel. So if you see this periodic table, cobalt is actually placed after nickel and not before nickel.
No more spending your energy and money on coaching classes or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Now we'll try to study different properties of periodic table. There are very few properties which we have to study in this chapter. First one is valency, second is atomic size, and metallic character and non-metallic character. Now before going actually into valency, let us understand what is valency and why valence electron is also need to be studied for valency. Valency is basically an effort an atom of an element can put to complete its octet, or the outermost shell has a complete set of electrons, 2 or 8. See, let us take an example. Lithium has one outermost electron. Why? Because it is the member of the first group of this periodic table, which means it has one outermost electron in this outermost shell.